Okay, so see what do I see here? I see. I think I see the boundary lines correct, and I think I see the graph correct. And I assume that the same will be true in the others. I'm not going to look at every detail of every paper. And I see a reasonable attempt at the second problem. I see some plus or minuses there, and it's definitely either a plus or a minus. I'll go over these in detail. These are kind of central. And then we'll talk about inverse functions. Okay, let's see. I don't see x equals 7 or y equals 11, but I do see 7 and 11 as labeled as coordinates. I don't see the coordinates of the x boundaries, but you want to write them as equations. X equals y equals, okay? Now, numbers are right there, right? You had to do y equals and do the x boundaries, okay? So, you know, and the shapes of the graphs look real good. But all the trouble of doing the construction lines, which, think about it now on a test. If I want you to do an accurate graph with construction lines, I'll say something. All right. If you just show me what the graph looks like in the box, I mean, it's got to go through the red dot the right way. It's got to have the right shape, the right general shape. So you should know the details of the shape. I'll talk a little bit more about that when I work through these. And the test, incidentally, I'll be in the testing center on Thursday. I'll actually probably put it in there on Wednesday if I get it done. Okay. And I've got it about half done. The problems will vary. In other words, if I ask you to do some function and with the red dot at some point, okay, somebody else might get a different function. And the point will probably be different. Maybe if you get the same function, somebody else, the points are going to be different. Okay. So there's going to be some variety in the problem, but there'll be equivalent problems. So you got a little bit of luck as a draw. You haven't got to be prepared to do everything. And if I ask you to do, let's say, the reciprocal function, you say, oh man, I don't know how to do that. Give me partial credit, and I'll do the exponential or the square function, whichever you find easier. I'd accept that for maybe half credit if it's not right. Okay, that sort of thing. But you should know that. I don't see the right shapes, but I do, and I don't see the right construction lines on a couple of the graphs, but I do see the right construction lines. On one of the graphs, however, they're not spaced right. Twice as close means twice as close. I see coordinates, correct coordinates, next to all the construction lines. Okay. And the boundary, but I don't see x equals and I don't see y equals. And you want to reinforce that. I'm going to use that terminology. I might ask you to construct a graph with boundary lines x equals 7, x equals 11, y equals 4, y equals 8. You have to know what that means. Okay. I would make that much variation in what we've done. I haven't asked you to do that yet, but if you've done everything I've asked you by labeling these things, you'll know what to do. You'll know what that means. Okay. I've just warned you about that. Because that could happen. Now the graphs I see here look good. And don't see answers to the second question. Another lesson on taking the test. Don't get hung up on a long problem that you're not sure you know how to do anyway. When there are shorter, easier problems waiting for you to get credit on. Okay. I don't put a time limit on the test, but eventually you're going to pass out. Okay. Or something's going to happen. Your mind, you're going to develop brain fog. Do the easy stuff first. It helps build your confidence. It gets you the points that are easy to get. So you beat your head over the ones that are hardest to get. Okay. That's just a standard test taking procedure. There's no time limit. People spend weeks in there on a test, but they can't because of the testing center closed. Allow yourself plenty of time. Okay, so let's see anything new here. I see something about a square root function here, and there's no square root function involved in any of these. But you might have read the square function as a square root function. And I think kind of did the right thing. But then you had the square root function on all three of them. That would. Okay, we'll talk about the square root function in a little while. So I'm glad you're aware of it. You probably saw a lot of it on the homework. Okay, so it's natural that you got the square root function running through your brain, and you put it down. So make sure you focus on what the actual situation is. I'm seeing pretty good. So far, just about everybody I've seen has the correct coordinates in the red dot. But of course, the red dot for the reciprocal function, you should know this backwards and forward. You should run each of these functions at least a dozen times. You should be totally familiar with them. You should practice it. It's the foundation. Okay. You want to master that, you want to have a tangible understanding of these graphs and these functions so you can relate it to the algebra. Just not seeing the red dot in the right place on that. But the coordinates of the red dot usually look pretty good. Don't see the coordinates of the red dot on this first graph. I've seen them in the other two, and that's really corresponds to the ones I asked for. But I also see reasonable numbers on the construction lines. Again, I don't see X. That's just to remind you, once you've got that, when you look at it, you won't mix up X and Y. And that's easy to do if you have a brain like mine. Okay. So that's just kind of an overview of what I'm seeing. Most people didn't get to the second part of it. They gave me about 6 minutes. Yes, do that. But I understand when your head is deeper into one problem, it's hard to pull it out and move it. So what I'm saying isn't where it needs to be at test time. Okay. And I don't know if I mentioned it. But the test will be in there until the following Thursday. You have a wide range of options for when to schedule your performance test. Okay. So you should be able to. Okay. Well, what I'm seeing is progress. Okay. And I think you're in striking distance of practicing on these graphs and sort out everything that I'm telling you. Okay. So I'm going to do these and show you what I was hoping to see. And I pretty much saw most of the papers. All right. So F1, F2, and F3 are the basic toolkit scoring exponential restricted functions. So find the red dot for each of these functions here. And sketch it in an appropriate 4x4 rectangle and label boundary functions. So abbreviating, it's a square function. We understand it's the basic toolkit square function, the one you would sketch in a 4x4 rectangle with the red dot at the origin. One of X is F1 of X minus 3 plus 7. That corresponds to H equals 3, K equals 7. Now, if you thought H was -3, you're going to have to fix that. But you know most of what I saw looked pretty good, and I didn't really look to make sure that coordinates of red dot were all right, because a lot of people didn't put the coordinates of red dot there. Okay, as I'm going to do. Okay, H is 3, K is 7. It's a squaring function. Okay, it's a squaring function. So right away, you know that the rectangle is going to look like this. And it's going to be 4 by 4, right? So you can immediately do that. And then you can say, okay, well, this is HK. You could even write HK equals 3, 7. Label that red dot, not over here or over there on a different page, right there on the graph where I can see it, right? And you can see it, so you have it for reference. The most obvious place. Okay, now we want to label the boundary lines. And we're only labeling the boundary lines, but you know, a lot of people are going to want to draw this line. This is the line x equals 3. Just for reference. And we do that because we know what H and K are. And then the horizontal line through that point is y equals 7. X equals y equals. You got to get that in your head. And you're going to only get it in your head if you write it out every time you do it. Okay. And it's easy. You just keep writing it out, it's going to become second nature, and you're going to have a deeper understanding of coordinate system. Okay. So we have that. It's a 4 by 4 box. So let's see, this distance is 2. You don't have to write this in. But I'm going to write it in just as a reminder. It's a 4 by 4, and this is in the middle of the lower edge. So you got 2 units this way, 2 units this way. So let's see. If x equals 3 here, and you go 2 units to the right, x is going to be 2 more. Draw a dotted line through the bottom. Just so that I don't clutter up the rectangle with a bunch of stuff. You know, the y equals 7 and the x equals 5 aren't right together. They're separated a little bit. The dotted line allows me to a little more room to label something. So I kind of recommend it. If it's here, okay. If I know that you mean this line, just put y equals 7, x equals 5 here, and don't tell me which line it is somewhere or another. I'm going to figure, yeah, you probably know, so I'll probably give you credit, but you didn't really do it. Okay. Okay. I wouldn't penalize it too heavily right now, but later on, I probably just most every penalties. Okay, so 2 units to the left of x equals 3 is obviously x equals 4. Everybody should understand that. Okay, and then I've got 3 of my boundary lines already labeled. This one, and this one. So I label this. And it's y equals what? Well, this is 4 units from here to here. That's obvious. That's standard. And it's y equals 11. Make sense? So that's what I wanted to see. That's almost of it. You know, you saw construction lines with the right numbers and stuff like that on a lot of papers. Okay? So you obviously understand, but that's all that was necessary. If you're on a test, don't do a bunch of unnecessary stuff. Okay? Now, if you're not sure whether it's necessary or not, yeah, go ahead and do it. Tell yourself, but okay, so we construct the graph. Then the graph is going to look like this. You know what the shape is going to be. You've drawn it dozens of times, right? Well, I hope so. So you know how to shape that curve fairly well. I'm not going to grade the shaping of the curve. Of course, show me a V, I'm going to say, yeah, that was an absolute value function. You should know better. I won't give you partial credit, but if you do everything else right. But depending on how much the question I ask depends on the fact that this has an upward concavity. Okay. There it is. That's all you have to do. And again, most of you spent way too long in that. I do with construction lines. So some people can't help themselves. You gotta be meticulous. I understand. Test's gonna keep you in there a long time. Because I'll design it. Well, you don't have to be meticulous on everything, even though you're probably gonna have to show me pretty much if you get something. You won't have to show me every time. Okay, well, anyhow, there it is. And then the other graphs. The exponential function, red dot is still here. So that's 2 to the x. V2 of x is F2 of x plus 8 minus 4. This is a form F of x minus h plus k, where h is negative 8, k is negative 4. So now I know what the red dot is. It's the point negative 8, negative 4. And I didn't leave myself much room to label this. I'm going to throw the label in about here. Not a good idea. I know where I'm going with this. I know that's not going to be much of a problem. I should have left myself more room underneath there. Okay. So, okay, so now you can label. It's got to be x equals, or sorry, y equals negative 4. See how easy it is to mix up x and y? This is x equals negative 8. Okay, well, it's 2 units this way. So if x equals negative 8, 2 units to the right, that has to be x equals negative 6. 2 units to the left has to be x equals negative 10. And 4 units up from y is negative 4 is y equals 0. Okay. There it is. Everything I asked. Except the sketch. Sketch, you know, starts at the left edge on the lowest construction line. And really all you gotta know is it's pretty close to just do a ballpark graph. It's pretty close to the x-axis, right? Then it gets steeper and steeper as you go to the right. Now, another thing is it should go through the point where 1 unit above the red dot. Okay, because when you subdivide it, you do this, and then you do this, it's on this line, and that's the y equals 1 line if you do the basic toolkit function. But the point is 1 unit above the red dot. If you know that, you get a more accurate graph, but I'm not going to grade it badly if you do that. Just don't give me a straight line or a line that's concave down. Okay. And then if you practiced it, you're probably going to draw it pretty much the way I did. And that's not totally accurate. Let's say the 4 that you still figure. Yeah, that's even a little bit high. And that's probably not exactly the right place. Not worried about that. If I just ask you, show me the shape. Okay, I ask you to draw me to construct the graph. And that's, if I say draw the graph, just draw a reasonable graph. Construct the graph, draw the lines, construction lines, okay. Makes sense? And as I say, most of you did reasonably well with this. Just clarify what we mean. And if you're reading the dead horse, now we're going to do the reciprocal function. So shape that one throws people a little bit. Okay, so it's a reciprocal function. It's our reciprocal function. You don't have to draw the lines through the middle, okay? But it's often helpful to, okay? It's not a bad idea to draw those lines. That's your option, okay? And this point Well, that's reciprocal function. F of x minus 8 plus 12. This is the form. H is 8, K is 12. This point then is point 8, 12. Anticipating where the curve is going to go, I'm going to label it right here. So they know the curve is going to be like this. And so you should know the curve is like this and like this. Now, if you don't know and you get in there and you know what the rule is, you can draw the construction lines and do it. Okay. But don't show me a curve that starts over here and ends down here. Okay. Don't show me a curve with a straight line. Concave in the wrong direction. Okay. Show me if you know what that curve looks like. And if you're a little too close here, that's okay. If you're a little too close here, that's okay. But by all means, don't hit this point here or this point here. Okay. Shows me you don't understand the rules. Right? Okay, so there it is. And that 12 is really bad. So I'm going to slow it down. Okay. Boundary lines. Okay. You don't have to label this, but it's not necessarily a bad idea to label this as y equals 12 and label this one as x equals 8. I didn't ask for it, but you're going to be a little more secure then when you tell me that this line leading 2 units or this one is y equals 14, and this line is y equals 10. And this line is x equals 10. 2 more than 8. And this line is x equals 6, 2 less than 8. Okay. So that's all I asked for. If you show me more, a lot of times it looks really good. Okay. So that's okay. But again, took so long that most people didn't get the answer to the same question, which is also. I'll also say that I didn't ask for it, but I could have. You probably will. You should know that the squared function has formula x squared, toolkit squared function. That's what the F1 is. So F1 of x minus 3 plus 7 is called G1 of x, which will then be x minus 3 quantity squared plus 7. It's just replacing x by x minus 3 as it is, and then adding 7 for the exponential function. F2 of x is 2 to the x is 2. And I gave you the 7x plus 8 minus 4. So then you just replace x by x plus h, you get 2 to the x plus 8 minus 4. And F3 of x is 1 over x. So G3 of x, which equals F3 of x minus 8 plus 12 equals replacing x by x minus h, because this x has been replaced by x minus h. We get 1 over x minus 8 plus 12. Very formulas. I can then ask you things like, okay, estimate the point where x equals 10.3. Okay, 10 x can't equal 10.3. Let's look at the one. Where x equals 4.3. Okay. Well, you go out to what 4.3 ought to be, you go up here and you go over here, and there's your estimate. And then compare that estimate with what you get when you plug 4.3 in here. Okay. What's my estimate? That looks like about 2.6. Let's see what it is. You square 1.3, you get 1.69. It's not 2.6, it'd be 9.6. You get 1.69 and 7 is 8.69 as opposed to the 8.7 I estimated with my eye, ballpark estimate. I didn't do any calculating. Closer than I would have expected from that. Very sloppy estimate, but I love that. I can ask you to do the same thing to any of these. Give you X, find Y, or give you Y, find X, and then verify. So here I said, okay, Y equals 3. So you draw the line, Y equals not 3. Let's see, Y equals 4, 0, Y equals -1. Okay, and you get your X value there, and that's between -8 and -6, about -5.3. Okay. Then I plug in -5.3. Okay. And see if I get Y equals -1. And I don't feel probably off a little bit, but if I plug in 5.3 here, this is going to give me something that if I've done this right, ought to give me -1 or something close to. Okay. Yeah. And William told me he had 12 threes, so I just summed it up because he's mad. Okay. It's 1 3. Yeah. Yeah, in the corner. Then I can ask you something similar about this. You get the idea? Those are the things I can ask you about these graphs. And that's a lot of what I could ask. And I'm going to give you a homework problem over the weekend that asks you pretty much everything. Okay. If you can do that without having to look at any materials or explanations or reference, you're in very good shape, or at least that kind of problem. Okay. If you can do it with, little look back at your notes and stuff like that, well, then bring that together into what you really need to know and make sure you know it when you come in and prepare for this test. And I suggest you start your preparation this weekend with that problem and maybe reviewing a couple of other things. Okay. Now quickly, these formulas. Stretch factor 3. Give you 3 off that. Think about the x-axis, that means whatever y is, it's going to change its sign. It's going to go negative, or if it's negative, it's going to go positive. Okay. That's what happens when you reflect about the x-axis. If you don't understand that, read the materials, look at the examples. Okay. That's what a reflection does. Then Horizontal shift of 12 gives you negative 3 f of x minus 12. And then vertical shift is negative 6. You get negative 3 f of x minus 12 minus 6. Now, it didn't say anything about g of x, but you call it g of x if you like. It's not a bad idea. Call it h of x. Call it del of x if you really want to. Okay. Call it anything you like. Anything. Okay. Or you don't even necessarily have to call it anything. But your function would then be negative 3 f1 of x minus 12 minus 6. f1 of x is x squared. That's negative 3. That's x minus 12 squared minus 6. F2 of x, g of x still equals negative 3 times the function, but now it's f2, x minus 12 minus 6 equals negative 3 times that's exponential function 2 raised to the x minus 12 minus 6. That's very different than this function. But what you do with that 4 by 4 square is the same in every case. Now there is one other thing you have to do with the 4 by 4 square to get these. Let's show you. Down. What do you get? And we'll call this now G1 of x, G2 of x, G3 of x. Okay. You want to distinguish it. Yeah, and I'm not too worried about what you call it. This is what I want to see. Okay, well, how would we construct now the graph of each of these? Okay. Well, here's your 4 by 4 square. The red dot at the origin. Vertical stretch by a factor of 3 makes this into taller rectangles. You're vertically stretching it. Now you're not changing the position of the origin, but you're vertically stretching it. It's now 12. That's after vertical stretch. Then a reflection. Well, here, but over here, now it's upside down. Okay, well now, after we've done our vertical stretch, we can sketch our graph. Of course, the upper corner becomes the lower corner. Now, if we are doing the squaring function, graph's gonna look like this. If the square graph is just gonna be stretched out, get skinnier. Okay? Didn't draw that very well. And here, we can just do everything upside down. Okay, so right now, this is line y equals 4. This is x equals -2. X equals, we probably can't read that. But that means down here, this line is y equals -12. This line is still y equals 0 because y equals 0 is the x-axis. And we're flipping it around the x-axis. Whatever's on the x-axis stays where it is, and that includes a red dot, still on the x-axis, which is y equals 0. So, we've got y equals 0 here. Y equals 0 here. Now y equals 0 is here. Now what do? Well, we move the red dot to the points, this function, 12, 6. Is that what I said? 12, -6. That's like 12, 6. Yeah, I'm starting to lose it. Okay. So we can say how this graph looks exactly the same. Red dot is here. As soon as we finish with stretches and vertical stretches and reflections, that's not going to change, okay? But now the red dot is at 12, -6. So this is now y equals -6. And this is 12 units here. This got to be y equals -18. And of course, x is 12 here. Put that in parentheses because you don't absolutely have to do it. It's very helpful to have that, because then you can see clearly why this is x equals 10. And this is x equals 14. And if you've got your construction lines, you make all kinds of good estimates. And even if you don't have your construction lines, you can make estimates. So if I want to estimate x when y is between -6 to -18, or a third of the way I go forward, so let's say here. Estimate x for y equals -10. Is that gremlin trying to get out of the cabins back there? Those guys are really, just be rough with them and they'll usually behave. Okay. Just kidding. Okay. Estimate x for y equals -10, right? Well, we got two estimates. This line and this line. Okay, this line is between -10 and 12. It looks like about 11. And this one looks like about 13. Okay. Now we can plug that in. Our function should be this, right? Well, you can verify easily G1 of 11 is -9. And G1 of 13 is -9. Just plug 11 in for x, you're going to get -9. If you plug 13 in for X, you're gonna get -9. And it's good to do that and not use your calculator because all you're gonna be scoring is 1 or -1. It's simple arithmetic you can do in your head. You should try it out. If you rely on your calculator, you miss a connection. Now, if your answer is, it's G of 11 equal, your estimate is 10.9836425. Well, you'd want to use your calculator to square that, right? But if the numbers are easy, you can do it. So that's close to -10. That's not bad for this. Okay. Now I'm going to lay one more thing on you that you want to think about, but it's not going to be in the test yet. But it will be a future test. So you want to start thinking about it now so it doesn't cause you problems later. Get the accurate value. Oh, you're right, -3 times X minus 12 squared minus 6 equals -10. That's what you're asking, right? You want this to be true? So you've got an equation. And it's pretty easy to solve that equation. Add 6 to both sides. You get -3 times X minus 12 squared equals -4. You add 6. Now we're adding 6 to both sides, and I don't have time or room to write all that out. We add 6 and we get this. Then if you divide both sides by -3, you want to write out the steps. I'm not going to take the time, just kind of demonstrating what you get. You get 4/3, which is approximately 1.33. You should kind of know that. Punch your calculator, go ahead. So now here's the mystery step. X minus 12 is equal to plus or minus the square root of 1.33. So X equals 12 plus or minus the square root of 1.33. Now all these steps should be familiar to you. So you do a little algebra, you be able to do your basic algebra, okay? And I think I warned you last time about square equals something, didn't I? Did we talk about that? Or was that in the other class? How are you looking at me blank? So maybe it's in the other class, but you should know that. Okay. If something squared equals a number, then that something is plus or minus the square root of that number. If it's not plus or minus, you're not going to get two solutions. And you see, you have to get two solutions. Now we're going to talk a lot more about that when we talk about quadratic functions, which is what this is. So there's a section coming up on that in a couple of weeks. And we'll talk about the details, but I want you to see that now. You should ponder this. Okay. Now I did that at the expense of leaving myself only 6 minutes. Talk about inverse functions. We talked about inverse functions at all last time. I don't think so. The idea of inverse functions is really easy. You just swap X and Y. So for example, do this in the dots. Here's your graph of the exponential. Okay. Note the points are -2, -2, 1/4. -1, 1/2. You should know this really, really well, having drawn this graph and labeled it and listed these coordinates a number of times. Have 0, 1, have 1, 2, we have 2, 4. So we make a table. X, y equals 2 to the x, -2, -1, 0, 1, 2, at 1/4, 1/2, 1, 2, 4. Here we have x, y equal to the inverse of 2 to the x. You know what we do to do that? We just take these two columns and we switch them. We put our 1/4, 1/2, 1, 2, 4 here. And we put our -2, -1, 0, 1, 2 here. There's a table for our inverse function. All right. Now, if we graph these, we'll have a graph of our inverse function. There's a little bit of complication there because we graph these. We have some negative x values. Remember, of course, that the x equals 0 here. We got to go down to x equals -2. You know, we can kind of do that. We could actually, we could draw our 4x4 rectangle like this. The red dot where it is, which will now be on the left. And we could locate these points, or we could just construct a regular old graph. Okay. Maybe we do it this way. We've got these 3 points and 5 points. Here's y equals 4. Here's x equals -2. Draw this. We need y equals -2. 2. Well, we'll have our y equals 2 line. We'll have a y equals -2 line. And now we can kind of locate these points because here's x equals 2. Now we're going to need x equals 4, and that's going to be out here somewhere. But now we can locate the points. -1/4, -2. Where's 1/4? This is 2, and this is, of course, x equals 0. Here's x equals 1. Here's 1/2. Here's 4. So we got to point out 1/2 -1. Well, y equals -1 here. It comes like this, and 0, and 1. And out here before we get to the graph like that. Okay, well, if we do the same thing with the squaring function, I'm going to just put the squaring function here and not necessarily have the coordinates on it. We can throw away this part of the squaring function. And we can reverse the coordinates of all these points. And what we get is a graph that looks like this. So this is y equals x squared. This is y equals the square root of x. That's the inverse function. Okay. Now to do the algebra to find an inverse function. So I've just drawn 2 inverse functions. This is called the log base 2 function that we see a month down the road. You don't have to worry about it. But the square root function, you've already seen square roots and done domains and ranges and a bunch of other stuff with square roots. So what you have to do, let's say that y equals f of x equals 2x plus 3. inverse function. F of x, we've got y equals 2x plus 3. Inverse function, we write this way, f to the -1, that's not really, we're not raising anything to the power -1, that indicates inverse. Okay, all we do is we switch x and y. We solve for y, get y equals x minus 3 over 2. So there's our formula for f inverse of x. One more thing quickly. F applied to f inverse of x equals 2 f inverse of x plus 3, because x has been replaced by f inverse of x. F inverse of x is x minus 3 over 2. So we replace f inverse of x with this. 2 divides 2, so we just end up with x minus 3 here. Then we've got a plus 3. That's just equal to x. So if you take a function, write it as y equals, switch x and y, solve for y, which sometimes is impossible, but the ones you're going to see it's possible. Solve for y, and say that's your inverse function. And then do f of f inverse of x, just using function notation, composition, composite functions, as I think you're pretty good with right now, because you're pretty good on the composite function sign. If you do that, you're going to just end up with x. Furthermore, if you do f inverse of f of x as open math will tell you, you're going to end up with x. Okay? So we'll talk more about what that means after we work through the assignment. Fair enough?